Hello, dear students. Hope you're doing well. We're back with chapter 3, section 1. In this section, we'll talk about atoms. What are they made up of? How did scientists figure it out, and how they thought at the beginning, and how their ideas have changed. So, first of all, let's talk about Democritus, in which he says that, or he called the nature's basic particles atoms, meaning that matter is consists of tiny particles, we call them atoms, and you cannot divide it into simpler substances, but later you'll see that this is not 100% true. Then Aristotle, he did not believe in atoms. He thought that everything or all matter was just continuous, everything made up of the same thing, continuing each other. The foundations of the atomic theory in late 700s, the chemists, they accepted the modern definition of an element, in which we know right now that elements, they are substances that cannot be further broken down by ordinary chemical means, meaning you cannot break it into simpler substances into more than one thing. Let's say we have oxygen, you cannot change it into more than one element, for example into hydrogen and helium, let's say. This is the definition of an element. So when elements, they combine together, they form something, we call it compounds, in which they have different physical and chemical properties. For example, again, when we have hydrogen and oxygen, something like this, bonded together, so two atoms of hydrogen bonded to one atom of oxygen, this is a compound. Why? Number one, because it consists of more than one element, which is hydrogen and oxygen. Not more than one atom, more than one element, different elements. But let's say we have hydrogen, H2, we have two atoms of hydrogen bonded together, but it's just one element, so this is an element, and this is a compound, more than one element bonded together, attached together. Something else that in which they have different physical and chemical properties. For example, water, in nature it is liquid, no color, right? Oxygen and hydrogen, the atoms inside water, if they're alone, oxygen, it's a gas. Hydrogen, it's also a gas. This is highly flammable gas, this is colorless gas. So look, each one of them has their own different physical and chemical properties. So basically, when atoms of elements, they combine together to form a compound, they lose their identity, they no longer have the same identity. So do elements, we have a question, do they always combine in the same ratios when forming a particular element? For example, can 3 atoms of hydrogen bond with oxygen and we call this water? So the ratios, the numbers are changing? No. It's always 2 atoms of hydrogen bonded to 1 atom of oxygen. So the ratios are constant. That's why we have the law of conservation of mass. We have 3 different laws in which they are very important. Number 1, the law of conservation of mass. It states that mass cannot neither be created or destroyed during ordinary chemical reaction or physical changes. So let's say we have hydrogen and oxygen. They combine together, they react with each other, they form water. Let's say we have 2 grams of hydrogen with 1 gram of oxygen. This whole thing, when they combine, they should be like 2 plus 1, 3 grams. So the product should also be 3 grams, because you cannot destroy it into nothing, into thin air, for example. Number 2, the law of definite proportion states that a chemical compound contains the same elements in exactly the same proportion by mass, regardless of the size of the sample or the source of the compound. Water, as we said, is H2O, 2 atoms of hydrogen with 1 atom of oxygen. It doesn't matter what source of this water is. Let's say it's a glass of water, still H2O. The ocean, still H2O. Ice, still H2O. It does not change. When you're changing the compound, you're changing the chemical formula, the identity is also changing. So that's the law of definite proportions. The law of multiple proportion, it says that if two or more different compounds are composed of the same two elements, then the ratio of the masses of the second element combined with a certain mass of the first element is always a ratio of the small whole number. What does that mean? We always have small whole numbers as the subscripts. We never have, let's say, 1,000, 100. It's always small whole number. Let's say we have N2O4. Can you simplify this? Yes, you divide it by 2, right? So the simplest formula is NO2, meaning that this N2O4, we have 2 molecules of NO2 bonded together to give this. Okay, so we always have them in small whole ratios. Next, we have Dalton's atomic theory. We have some points to discuss. Number 1 is, he says that all matter is composed of extremely tiny particles. What do we call them? Atom. Let's say we have hydrogen. Hydrogen consists of atoms of hydrogen. Oxygen, atoms of oxygen. If you use a special microscope, you will see that we have atoms. Number 2, atoms of a given element are identical in the same size, mass, and other properties. Atoms of different mass are different. Let's say this is hydrogen, this is oxygen. Atoms of hydrogen, all of them are the same thing. And atoms of oxygen, all of them are the same thing regarding the size, the mass, their properties, everything. They're identical. But let's say, are atoms of hydrogen and oxygen the same? No. Each one of them has their own identity. So we never see, let's say, we have atoms of oxygen with only single atom of hydrogen. We call this oxygen. No. Okay, it's never like this. All of them are identical, but different elements, hydrogen and oxygen, each one of them have their own different type. Number 3, atoms cannot be subdivided. You cannot, here is saying that you cannot divide atoms into simpler substances. You cannot create them, which is true, or you cannot destroy them into nothing, which is also true. But about subdividing them, you will see later on. Number 4, atoms of different elements combine in simple whole number ratios to form chemical compounds. As we already mentioned about this example in 204, it's always small whole ratios. We never see hundreds, 20s, or stuff like that. Number 5, in a chemical reaction, atoms are combined, separated, or rearranged. Let's say we have hydrogen reacts with oxygen to produce H2O. Look here, hydrogen is bonded to hydrogen. Here, oxygen is bonded to oxygen. But here we have 2 molecules of oxygen bonded to hydrogen. So you're just rearranging them. You break this bond, and form another bond between oxygen and hydrogen. That's why you never lose any atom. So according to Dalton's atomic theory, how does the law of conservation of mass works? As we said, for example, we have carbon reacts with oxygen to form carbon monoxide. So we have, let's say, 5 grams of carbon react with 5 grams of oxygen. The total carbon monoxide should be 10 grams. Okay, it should be constant. It should not change because you cannot create it or destroy it into nothing. The law of definite proportion, on the other hand, it results from the fact that given chemical compound is always composed of the same combination. So carbon monoxide is always 1 carbon, 1 oxygen. Carbon dioxide is always 1 carbon, 2 oxygen. So look, it's always like this no matter where the source is. The law of multiple proportion, for example, carbon dioxide, we have oxygen, look, we have oxygen and carbon. So we have here, we do not have a number, meaning it is 1. So we have 1 carbon, 2 atoms of oxygen. This is the ratio, this is how we call it. So we say carbon, 2 oxygen, the ratio is 1 to 2. If you flip it, we say oxygen to carbon, we say 2 to 1. So just write them down right beneath it and form your sentence. In this case, oxygen is twice as much as carbon. The last thing we have, which is the modern atomic theory. The things that Dalton have mentioned or have discussed, a lot of them might not be true or not 100% true. So not all aspects of Dalton's atomic theory are proven to be correct. For example, atoms are divisible into smaller particles. He is saying that they are not divisible. You cannot change it into smaller particles. But later you will see that, yes, we have a nucleus and we have electrons around it. We have protons, neutrons. So this is an atom, so you can divide it into simpler substances. Number 2, a given element can have atoms with different masses. We call these isotopes. Same element, different masses. For example, hydrogen. We have hydrogen 1, we have hydrogen 2, and we have hydrogen 3. This is normal hydrogen. This is deuterium, and this is tritium. Look, there are still hydrogen, but the only thing that is changing is their mass. And we'll discuss this later on.